Hello, my name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 283. Please turn to page 283. Today is our lesson number 122. Problem number 96 is what we're going to do. Problem 96, it says that this symbol here denotes the least integer greater than or equal to x. That's what this symbol denotes. And the question simply is x in this symbol equal to 0? Now listen, before we start actually solving this problem, I'm going to tell you exactly what happened as I read this problem. And what I'm about to say is without exaggeration, this is honest to God truth. I had to actually pick up my magnifying glass. I had to pick up a bloody magnifying glass to be able to tell, to be able to perceive the difference between the symbol that they're using here and the symbol for the absolute sign. For the absolute sign, you will simply put down two lines like this, but that is not what is here, because that would have meant absolute value of x. That's not what they're talking about. They are usually being cued, but here in this example they are being extraordinarily cued. This is the symbol that they're employing right here. This is it. I do not know what would have caused them to actually have put on the bottom also, so that it's easier to see. They did not put the thing on the bottom. That is the symbol that they're using. To avoid the confusion, to make our life easier, so that it's not annoying so much, we're going to use a different symbol. We're not going to use this symbol. We're going to create our own symbol. Let's put a box around it. It's easier to see. It's just a symbol. What it simply means is that when we see a number, for example 0.1 in a box, it equals the least integer that is greater than 0.1. What is the least integer that is greater than 0.1? Least, of course, 2 is greater than 0.1, 5 is greater than 0.1, 2 is greater than 0.1, 1000 is greater than 0.1, but what is the least integer that you can find that happens to be greater than 0.1? And that, of course, is 1. That's what that means. 0.1 in a box, in this example, in this question, would mean 1, because that's the closest that you can get to a whole integer. It has to be the least integer greater than or equal to x. You see here, if you were to draw it on a number line, if you were to draw it on a number line, here is our 0, and 0.1 would have been here, 1/10, and 1 is way over there. Now, they're not looking for the closest integer to 0.1. They're not looking for the closest integer to 0.1 because the closest integer would have been 0. This is the closest integer. But at the same time, it has to be greater than or equal to x. Since 0 is not greater than 0.1, therefore this does not equal, therefore this in a box does not equal 0. It has to be greater than or equal to x. So the closest integer that we can find, which is either greater than or equal to x, is 1. Let's do one more example. See if we can grasp what they're talking about here. For example, what would be the value of 0.00000001? What is the closest integer that we can find? Now, if we just stop at that, the closest integer to this quantity would be 0 again. What is the closest integer that we can find to this quantity that you see in the box, which happens to be greater than or equal to the quantity? Again, that will be 1. That is the closest integer. What's the answer to this one? 3 1/4. What's the closest integer that we can find to 3 1/4, which is the whole number, which is an integer, and either equal to or greater than 3 1/4? That will be 4. Let's do one last one. How about this one? That will be 7. This is where the equal to part comes into play. You see, the closest integer that we can find, that is either greater than or equal to 7 is the 7 itself. Voila. So now that we understand the question, let's do the problem. Okay, let's do the problem. Let's see what they tell us in the first statement. In the first statement they tell us that x is between -1 and +1. Is that how we actually say it? No, they actually put it in symbols. X is between -1 and +1. It is greater than -1 but less than a +1. It's between -1 and +1, as we just said. Now, what's going to happen here is that if x happens to be between -1 and 0, let's say for example -3/4, what is the greatest integer, no, sorry, not the greatest, rather, what is the least integer that we can find which is either equal to -3/4 or greater than -3/4? And that will be 0 actually. Again, we only shown the number line here. Here is our 0, here is our -1, and -3/4 this is -1/2, and -3/4 would be somewhere here. Again, -3/4 is very close to -1, but -1 is not the answer. But because it has to be greater than the quantity in the box. It has to be greater than or equal to the quantity in the box. Because it has to be greater than or equal to quantity in the box, it's not going to be -1. We have to go all the way from here, or we have to go all the way up to 0. Let's do one more. But if it turns out that if x happens to be something between 0 and +1, if x happens to be something between 0 and +1, say for example 1/2, then the closest whole number that we can find, which is greater than 1/2, is 1. If x happens to be 9/10, which is between 0 and 1, if x happens to be 9/10, again the value is going to be 1. So in this range, we can't really tell. The question was, is the quantity in the box equal to 0? Here the answer would be, well, it depends. If that quantity in the box happens to fall between -1 and 0, then yes, it is equal to 0. In this scenario, the answer to this question is yes. Is it equal to 0, the quantity in the box? The answer is yes. But if the quantity in the box happens to fall somewhere between 0 and 1, then the answer is no, because in that case, the value is going to be equal to 1. So here, in this scenario, the answer is no. We can't really tell, because it goes all the way from -1 to +1. So the first statement does not give us a definitive answer. First statement by itself is not sufficient. A, D, B, C, E. Because the first statement by itself does not work, answer cannot be A, nor can it be D. Let's look at second statement. In the second statement, they simply tell us that x is negative. That's all they tell us. X is negative. What this says is that x is negative. Well, x can be anything. Anything negative. For example, the quantity in the box could be -100. in which case the closest integer that we're going to find that is either greater than or equal to negative 100 is negative 100. Or the quantity in the box could be, negative 2.5. If that's the case, then the greatest integer that we can, oh sorry, I keep saying greatest, I meant to say least, okay? Every time I say greatest, I added it. The least integer, the greatest of course will answer will be infinity. The least integer that we can find that is still greater than negative 2.5 or equal to negative 2.5 would be 2.5. Because 3, so would be negative 2, because negative 3 would be less than negative 2.5. Negative 3 would be less than negative 2.5. So here is 2. Or x could be, for example, negative 0.000001. What is the least integer that we can find that is greater than or equal to this quantity? It's not 0. It's not 0 because 0, actually it is 0 because 0 is actually more than this guy. It is 0. It's not negative 1 because negative 1, first of all, is too far away from this one, and secondly, negative 1 is less than this quantity. So what's the answer here? Simply knowing that x is negative does not tell us anything. It could be any negative number. So second statement by itself also does not do the job. Therefore, the answer cannot be A, D, B, C, E. We found out earlier that the first statement by itself did not work, so the answer we knew could not be A or D. Now we find out the second statement by itself also does not work, which means answer cannot be B. It would have to be either C or E. Let's put them together, the two statements together, and if it gets us someplace, the answer is going to be C. If it doesn't get us anywhere, if we still cannot tell what the value of the box and what's the value of the x is in the box, is it equal to 0? If we cannot tell, then the answer will be E. Let's see what happens. Let's put them together. Together 1 and 2. The first statement tells us that x is between negative 1 and positive 1. The second statement goes on to tell us that x is negative. Well, if x is negative, and we know that it has to fall between negative 1 and positive 1, so the first statement tells us that it is, here's your 0, here's your negative 1, and here's your positive 1. The first statement tells us that it's somewhere here. The second statement tells us that it is negative. Well, if it's negative, it's got to be this part right here. That's it, it's between negative 1 and 0. So this implies that x is between negative 1 and 0. X is between negative 1 and 0. Now in that case, okay, let's keep listening. In that case, it doesn't matter what exactly x is. Here's your 0, here's your negative 1. If the quantity in the box happens to be negative 1, the answer would be, oh, but it cannot be equal to negative 1. We have to be very careful. Here, we do not have equal to sign. You see, I almost made a mistake. There is no equal sign there. So it has to be, it cannot be negative 1. Had this symbol appeared here, had they included this here, in this scenario, the answer would have been E, because in this case, it's negative 1. In all the other cases we're going to find just now, that it's going to be 0. That's why they ruled out this part. It cannot be equal to. It has to be greater than everywhere. In other words, if you were to show it with the plot, you would not close the dot. It will be an open dot. The dot will be open. It will be an open dot here, and you will show it like this. Not a closed dot. We cannot include the endpoints. So this is wrong. It cannot be negative 1. It could, however, be something damn close to negative 1. Say for example, negative 7/8. If it's negative 7/8, it's going to fall somewhere here. Here's your half. Here's your 1/4. Here's your 3/4 rather. Here's your 1/4, negative 1/4, negative 3/4. And negative 7/8 is going to fall somewhere very close to here. Again, the closest integer to negative 7/8 is not negative 1, but it is 0, because it has to be more than that. This is equal to 0. Therefore, similarly, let's do it on properly on the line here. Here's our 0, here's our negative half, here's our negative 1, and here's our negative 7/8. The value of this guy in a box equals 0. The value of this guy in a box equals 0. The value of this guy here, let's put something very close here, negative 1 over 1000, or negative 1 over 1 million, which is very close to 0, is also 0. They're all 0. So if we know that it falls somewhere between negative 1 and 0, then the value of the quantity in the box, regardless of what that quantity is, will be 0. Because we have to have a whole integer greater than or equal to the quantity in the box. And the quantity in the box cannot be equal to negative 1. It has to be more than that. Therefore, we will fall at 0. We will not go to negative 1. That's all. So putting the two statements together does do the job. Putting the two statements together does do the job. The answer is C. I do not know, I have no idea how you will evaluate it. Perhaps I explained too much. I don't know. Anyway, we are done with this one. I want to do the next one. Let's do one more. 97. First of all, let's change this marker. This marker is dying. It's annoying. 97. Actually, you know what? I'm not going to do 97 because I have the feeling that this video is long enough already. Let's save the 97 for tomorrow. Alright? I'll see you tomorrow, okay? Bye now.